Saxon Algebra 2, Lesson 90. Greetings, students. Prepare to feel smart. We're going to learn how to solve systems with not 2 equations, but 3 equations. That sounds really, really hard, but we're going to use mostly elimination. In this particular situation, we're going to use elimination just like we always have. There's nothing new or weird or different about it. And number 2, John's going to be really, really nice to us in the numbers that he gives us in our systems. So there's lots to look forward to. We have got 3 equations in a system, and each equation has 3 variables. As I copy them down, I'm careful to create columns. I wish I wouldn't have shoved it so far, but that's okay. And I'm going to skip a line just so it's super easy for you to see what I'm doing. Okay, there they are in all their glory. We're going to name them with letters just so we can talk about them. I'll double check it while you finish copying. Okay, now just like with the regular 2-part systems of equations, we're going to choose to eliminate either the x's or the y's or the z's. Now, you can make anything work, just like regular elimination, but the z's have the perfect arrangement, okay? They have matching coefficients. In this case, it's an invisible 1. But it would be fine if they all had a 3 or they all had a 47 because they all match. And then the other thing that they have that is lovely is alternating plus minus signs. This is exactly how we want it to look. Plus, minus, plus, or also adorable would be minus, plus, minus. But we want it going back and forth like that, and you'll see why. Okay, so this is our dream scenario. So we're going to choose to eliminate the z's. Here's the way that we do it. Step 1. We're going to add A and B. Okay, I'm going to copy them over. When you're doing the homework, you can take some shortcut steps, but I'm going to be super show it all. X plus 2y plus z, remember that's my z, equals 4. And 2x minus y minus z equals 0. I just copied A and B over again. And now I'm adding them. Oh wait, this should be an x. Right? Yes. So we have 3x plus y, that cancels, equals 4. Okay, we'll hold on to that. Step 2, here's where your mind may be blown. We're going to add B and C. Now, I remember being a student and thinking, okay, it's weird enough that in systems of equations we can add them together, but now you're saying that we can add them together more than once? Yeah, we can. Crazy but true. So we did A and B first, now we're doing B and C. That's why these 2 rules, they just make it perfect for us. So now I take equation B and C. We add those. Okay, so now what we have are 2 equations in a form that looks super familiar, right? So what we're going to do is we're going to create a new system out of these, 3x plus y equals 4, and 4x minus 3y equals 1. And we can solve this as usual. This is just a cute little standard. Here, I'm going to put systems on those, right? This is just our usual kind of friend. So I can see, okay, should I do the x's or the y's? This has already got the minus. And if I just multiply this top one by 3, I should be good, right? So I'll multiply it and I'll write it over here. It's 9x plus 3y equals 12. I gently squiggle that out so I don't get confused. I draw my line and I get 13x equals 13. John, what the heck? X equals 1. And now I just do my continued solving over here, just like we've done in the past. I'll take this first one, right? 3 times 1 plus y equals 3. Subtract, I'm sorry, 4. I was looking at that, 3. And I get y equals 1. And now we have to go back to one of our original equations to solve for z, because that's the only place we find our z's. Let's take this one. It would be 1 plus 2 times 1 plus z equals 4. So we have to subtract, let's see, 1 and 2. If we subtract 3 from both sides, z equals 1. Whoa, John, how did you make it turn out so cute? And so our final answer, we write this as an ordered triple, 1, 1, 1, for x, y, and z in order. Cute, right? Kind of fun. And we're going to follow this pattern. For this lesson, all the problems associated with this lesson, we'll follow this pattern of smush A and B, smush B and C. We won't always have this perfectly. We might have to do some adjusting to these, and I think our next problem will illustrate that. But for the most part, we'll always follow that elimination pattern of A and B and then B and C, just like we did here. That's not the only way to solve these, but it is usually a super effective and efficient way to get it done fast. This is the only other lesson, right? Yes, or example rather, in this lesson. Okay, here we go. 2x. I have found that taking your time to write these out really neatly pays off because you can see what you've got. And it helps just keep your brain straight. Which is half the battle. It's more than half the battle. It's 99% of the battle. Okay, you keep writing. I'll double check. Okay. And just like before, we have A, B, and C. And this is a big, fat, cute system. All right, so now we're looking down our columns, looking to decide which set of variables we want, which variable we want to eliminate. Wait right there. That fearsome sun is making too much of a shadow on my page. So I'm rigging up a little sunscreen. Okay, that's better, right? Okay, I like the alternating pattern of plus, minus, plus in here. And I see we've got 2 out of the 3 variables with matching coefficients. So if I just multiply equation A times 2, then it'll be just the way I want it, right? So what I'm going to do is multiply it by 2 and write it above so that it's right where I want it. That will be 4x minus 2y plus 6z equals 18. Squiggle this out. I don't want to get confused by that. Okay. I did it this way so I don't have to keep rewriting. Every time we rewrite, we introduce the risk of copying mistake. Okay, so now I'm going to combine A and B. This I will rewrite though. 4x minus 2y plus 6z equals 18. And B is x plus 2y plus z. Okay, just copying my newly adjusted A. John sometimes calls that A prime, right? He'll use that little, it's like it almost looks like an exponent of 1. It's meant to be read as A prime, meaning A with a change. All right, 5x, that's gone, plus 7z equals 26. I like it. Now, I'm going to add B and C down here so that I can write the answer. We'll call this, we'll call it A prime plus B. And then right underneath it, I'm going to write B plus C once I get that figured. B is x plus 2y plus z equals 8. C is x minus 2y plus z equals 0. I add them. 2x, the y's cancel, plus 2z equals 8. Okay, that I'm going to write here. 2x plus 2z equals 8. Okay. Now I have to do something to fix these because they won't eliminate as is, right? So I can either multiply by 2 and 5 or by 2 and 7. I'd rather multiply by 5. So let me use a different color again to help do that. Let's multiply this one by 2 and this one by negative 5. If all things are equal, I like to have my negative in the bottom row because that seems natural. Okay, so the top row, which is my A prime plus B times 2, is going to be 10x plus 14z equals 52. And this row, my B plus C, multiplied by minus 5, is going to be minus 10x minus 10z equals minus 40. Oh, that looks like it's going to work out really nicely, doesn't it? Now I'm ready to combine them. This cancels, as it should. 4z equals 12. Aw, that's so cute. Z equals 3. All right, let's plug it back in. We can plug it into really any equation that we have, but we want to have one that just has z in one other letter, because if it's got two other letters, we can't solve it. So it could be either one of these. I guess I would choose this one. So let me draw another box. We're going to plug z in to solve, and it'll be, I'm just kind of dividing off my paper. If I wasn't teaching, I would flip the page and just go on to another page because there's no point in trying to cram. But I don't like to switch over because then I can confuse you really easily. So we're plugging our value for z into this version because it looks really easy to me. 2x plus 2 times z, which is 3, equals 8. This is 6. So I subtract 6 from both sides. I get 2x equals 2. And that tells me that x equals 1, right? Divide both sides by 2. And now, right here, I will plug x and z in to solve for y. Let's pick one of these top ones. I'll pick up here. X, which is 1, minus 2y, y is the one I'm solving for, plus 3, because that's z, equals 0. So this is 1 minus 2y plus 3 equals 0. 1 plus 3 equals 4. So if I subtract 4, that will swim both of them. So this all cancels. I get minus 2y equals minus 4, and I divide. And I get y equals 2. John, how cute are these answers, right? This is fine. This is preferable. We want to write it as an ordered triple. Okay, so the method we used was exactly the same. Find the pattern that works best here. We chose the y's, although we did have to adjust one of these equations this time. Then combine A and B, combine B and C, compare those two, and then solve. I hope that makes more sense. I just said all that and I'm like, well, that confuses me to say it. But anyway, I hope you'll get a feel for these. They are usually wildly rewarding to students because once you get the hang of them, they're not hard, but they look really impressive, don't they? Look at that. It took us a whole page to sort that out. Congratulations on being brilliant. Yay, bye.